same key for encryption. We're going to use the same key for encryption and decryption. Okay. Yeah, this is going to be, this is one of the current, okay, we have seen that this is the one of the current technique, current algorithm which is used in cryptography for the security purpose. All right, and we have seen that in this AES or Advanced Encryption Standard, you know, the plain text is by default. The plain text is of 128-bit size. Okay, and we have seen that number of rounds, it can use round 10, round 12, round 14. Okay, round 12, round 14 depend, okay, based on what? Based on number of, based on size of key, size of keys. Okay, based on the size of the key. Namely, we may say if it is 128, if it is 192 and 256 bits, then the number of rounds will be respectively. Then the number of rounds, we say number of rounds are respectively. Okay, are respectively. Okay, this is what you have seen. All right, so today we are going to see for each and every step. We have seen that in this one, we use something called add. Okay, what is that one? The first step which this encryption or this advanced encryption standard uses what? We have some steps like shift low, the shift lows. We have like a mix column step. We have like sub byte, okay, sub byte step. Okay, add the new row. We have also the add new row, like that one. Okay, so we are going to see one by one how these stages, okay, I call them like a stages, how these stages vary. Okay, let's look to the share screen here, and we shall understand each and every stage. Okay, okay, I hope and I believe that you are able to take the note. You are able to take the following notes. So let me again bring the diagram of this advanced encryption standard, okay, of what we have seen yesterday. Yeah. Okay. So, okay. In this diagram, let me write it here because it's going to take a bit of time. Okay. In this structure, in the simple structure which we have seen from yesterday, what was that one? It was this way. We saw that the key, we are going to have the so-called the key, initial key 0, 128-bit. This 128-bit, it will pass to the add round key. Okay, this is add round key stage, and the plain text will be entered to this one. This is a plain text, and this is going to be followed by sub byte stage. It goes going to pass to sub byte stage, and this sub byte stage is going to follow what is the next? Shift low. The shift low stage. Okay, the shift low stage is going to be followed by the mix column. Mix column is going to follow the mixed column stage. Okay, and some of the joining late. Okay, so the mixed column stage, this is going to follow the mix. It's going to be the mixed column stage. The mix column stage. Clear? And this mixed column stage is going to be followed by the add round key again. Add round key again at the last. Okay. So as you can see, this plain text, okay, this plain text is going to enter here, and another key is going to be introduced here. Key 128, the round key. These are known as the round keys. These are the round keys. Okay, these are the round keys. So from here, we have the first round one. Okay, round one start. Remember, round will depend on the size of the key. Okay, now what happened in this round key? Let's see what happened in this round key. All right, so is the screen being shared to you all? Can you see the shared screen? Is it visible, the shared screen?
Yes, sir.
Okay, good. So in this AES diagram, when we talk about sub-byte key, okay, as you remember, you will tell me if you can be able to see the board. Is the board visible? You can see the board. Is the board visible as well? Yes. You will tell me, is the board visible? You can see the board? You can see the board?
Yes, sir.
Okay, good. So as you remember, in the units of data units in this cryptography, we have seen that the smallest is bit. Okay, the smallest is bit. The bit is followed by the bytes. Byte is made of what? Byte is made of 8 bits. Okay, now after this byte, the byte is followed by what? What is the next? Was it word? Okay, word. Word is made of what? Word, a word is made of how many? How many bytes? 16, right? 16. 16 bytes. 16, I mean 8 bits. 8 byte. 8 byte. 8 bytes. All right. So this 8 byte is made of what? The 8 byte is this byte, the word. Okay. This is made by 8 bytes. Okay. So the word is following by the state. Okay. State is made of 4 words. We can say state is of the 4 words. All right. So as you can see to this first diagram which we have there on our screen, when we talk something which is called the sub-byte, okay, what does it mean, the sub-byte key? All right, this sub-byte is going to use for in each state array is replaced with a sub-byte using 8-bit substitution. So it is where the substitution is going to take place. For example, the first one was A00, A01, A02, A, this is 0, A03. So the second, it's a matrix of 4 by 4. All right. The second is going to be A10, A11, A12, A13, A20, A21, A22, A23, A30, A31, A32, A33. Okay, this was initial matrix. Okay, so the sub-byte key is going to make a substitution. This is from what? This is from the byte. Okay, when you're going to form, this is from the byte. So when you're going to form a state, okay, we're not going to form a state. What is going to happen? They're going to be the substitution of the bytes, okay? They're going to be the substitution of the byte. They're going to make a substitution, all right? Look at example. It was A22 is going to be B22. It was like A22 where A22 is located. This A22. In the next is going to be the second byte B22 like that one. So it is going to do the substitution if you want to make the substitution in what in the next stage of state in the state, okay, in the state units. So this is going to make the S boxes. The S boxes they're going to help to strengthen the security or to strengthen the key, not the key, the ciphertext, by doing the multiplicative inverse, by making the substitution so that the encrypted plain text which is entered into this one, into our sub byte, then will be stronger and will be difficult for the cryptanalyst to find it, to decrypt it. The next one, which is the second step, which is very, very important, and this used to be, you know, one of the interview questions. How does the shift law, you know, works? Okay, at this stage, the second stage which goes is a shift law. All right, in the shift law, I forgot to tell you that this AES was developed. Okay, it was first developed by a man called Ladgel. I think is Ladgel. This one was a mathematician or physician. It was a Belgium, scientist. Let me call a Belgium scientist who developed the first AES. Okay, is the one who has developed the first AES. All right. So in this development of first AES, he suggests that the shift law should be in this way. As you can see for the first shift law, he mentioned that A00, A01, A02, A03, okay, will remain unchanged for the first one, okay, for the first one. For the second law, this is law 1, okay. For the law number 2, we are going to make a shift, one byte, okay, one shift, one step from right to left, okay. One shift from right to left means this was like this one. The initial was like A1, A10, A12, A11, A12, A13, A20, A21, A22, A23. The last was A30, A31, A32, A33. Okay, this was the initial box. Okay, initial box before the substitution take place. Okay, before the substitution take place. Now, the concept is say that the first law, this is the first law, remain unchanged. Means the first law in the next substitution, the first law will remain unchanged. How? Will remain as A00, A01, A02, A03. Okay, A03. The second law is going to shift one step from right to left. Okay, from right to left. We are going to shift one step from right to left. How? Look here. Here was what was this one? Here was 1, 1, 1, 2. Okay, 1. This is 1, 1, 1. All right. It's going to shift here. This is going to shift here. This is going to shift here. And what is the last? And this is going to shift here. And this is going to come here. Okay. We are going to shift one step from right to left. So here we're going to have A11, Okay, is it A11? Yes, A11, and then it's going to have A1, A12, and they're going to have A13, and they're going to have A10. Okay, clear? So we are shifted like that one. The second law, the third law, sorry. For the third law, he said, the concept said that we have to shift 2 steps from right to left. 2 steps. 2 steps from right to left. Okay? 2 steps from right to left. Where this one is going to be? This one is going to occupy which position? Okay, this one is going to occupy the second position here. Okay, the second position here, and the first is going to this one, and the remaining will be for 2 2. Okay, or 2 1, sorry. All right, the remaining will be for the 2 1 because this has already shifted. The remaining will be for the 2 1. So how is it going to be? We are going to have A2 2 here. Now you see this is the second 2 shift. Okay, 2 steps from right to left. All right, and again we are going to have the 2 3 was on the last one, so 2 is going to shift here. We start from right to left. Okay, now we have A2 3. Okay, A2 3, and now we have what one? We have, it comes 2 shift now. Is it A2 0? Okay, and the last is going to be A2 1. Okay, now the last law, the fourth law. The fourth law, it says you have to shift 3 steps from right to left. 3 steps from right to left. So it is this one. 3 steps from right to left. Okay, and what is the next? And this is going to be permitted like this way because there is no other go, because there is no other shift like this way. Okay, like this way, and this is going to be come like this way. So we are going to have A3 3. We are going to have A3 0. We are going to have A3 1, and they're going to have A3 2. Clear? So this is how the bits, this is how the bytes, they can shift internally in a shift row in order to make the strong key or the strong encryption. Okay, this is a shift row. It's a very important. You have to remember how does the first round works. The first round you are going to substitute is going to use the substitution of the bytes from the initial table to the state table. Okay, to the step table. All right. So the second one, we are going to use a shift law. In this shift law, what do we do? The shift law steps into this one. You have to explain how these things works. You have to mention that the first law remain unchanged. Okay, remain unchanged. Okay, second law, we mentioned the second law. What happened to the second law? The second law is shift the bits. Okay, shift from position from right to left 1 step. They shift 1 step from right to left, from right to left, from here right to left, from right to left, right to left, right to left. The third one, the third row, the shift is from 2 steps from right to left. Okay, from right to left. The third is we are going to shift from 3 steps from right to left, and the rest will be the same as it was. All right. So for the mixed column, okay, the next step for the mixed column. So the mixed column, what is the use of this mixed column? In the mixed column step, 4 bytes of each column of state are combined using invertible binary transformation. The mixed column function takes 4 bytes as input and output 4 bytes, where each input affected of this one, as you can see here, is going to take the 4 bytes of the input, and again is going to combine or to do the operation. As you can see, which operation? We are going to do XOR operation. Okay, we are going to do the XOR operation. Let me continue for the same here. Let me try to erase this one. This is for mix the column. Okay, this was about the laws. This was about how the law is going to be mixed. Okay, now this was the law, right? This is also low wise. Okay, low wise. Now the column wise, let me try to put into the table. Now let me put into the column wise. Okay, this is going to be the column wise. So in the column wise, we are going to mix, okay, the second column. We are going to take the second column of the input, and we are going to do XOR operation to form to the mix to the second column of the output, which we get from the row. From the first step, which you have seen is what? We have the mix row, right? Mix row. We have the mix column. Okay, we have the mix column. So this is going to be the output, and they're going to mix it again to the column of that input which we had. Okay, it's going to be the input, that one, plus the key. Okay, plus the key. All right, so yeah, the same add round key. For this add round key, all the work the same is by using the XOR operation, as you can see to the diagram here, mixed with the key. To the add round, because of what? Because of the add round key is this way. You remember, for the add round key, we want to take the input using XOR. This is going to be 128 key. This is going to be key. This is going to be key. This is a key. And this is going to go to the add round key. Clear? The add round key. So we are going to take the input here. Plain text will come here. We are going to take the plain text as input, this one, and the plus, or doing XOR of the key of 128 also, which is divided into the block like this one. Okay, and then we form the output. Okay, then it's going to form the output. So this is important structure. Please, I'm going to give you time to note it down. Okay, this is important structure. Please note it down. That structure, how the structure, how AES, the full structure is being designed. All right. So look here. We have a plain text here. We have the plain text. Okay. We have the plain text is going to pass to the add round key, substitutive byte, shift low, mix column, add round. It's going to be the first round. Okay, it's going to be the first round. For the first one, we are going to add, as you can see, it's like this way. We are going to have first one is the add round key. Clear? Add round key. So in this add round key, we are going to add the keys here. W03. What does it mean? We are going to use word. Okay, we are going to use a word unit. Okay, it's going to be a word unit. A word unit is made of what? Is made of 4 bytes. Okay, is made of 4 bytes. Clear? That's why I have a 0, 1, 2, 3. From 1 to 3. Okay, bytes. All right, this is it. All right, so when we add it, all right, when we add this key which is going to be added here. The key which is going to be added, we come to sub byte. It's going to have a second step, is going to have the sub byte. Okay, the sub byte, and this sub byte is going to go to the shift. We are going to have the shift low, the shift lows. Shift lows is going to be followed by the mix column. Mix column. The mix column, as you can see, the mix column here. Okay, the mix column. And when this step is done, okay, this step is done, then we have the last one, add round key, in order to start add round the key in order to start the second round. Okay, in order to start the second round. So this step here, from here to here, from here to here, this is going to form round 1. Round 1. This is going to be round 1. So when you're going to start the second round is going to start from here, right? We are going to introduce one more key, W47. 47 what? Because the key is going to keep increasing. And this will depend the number of key will depend on the number of round. Okay, it's going to depend on the number of round. So W47, and it goes on word 7, and it goes on to the last. If you have a 10 rounds, we are going to have W40 to 43. What? Every key will have 3 bytes. Every key will have 3 bytes. Okay, so we are going to have all these positions. Okay, which position is 0 to 3? That's all. So this will be the last one, and this will be the 10 round. The 10th round will be down here. Okay, the 10th round will be down here. So this is for plain text to ciphertext. And again, when you are going to shift from important points, when you are going to reverse it, as you are taking the note of this one, when you are going to again to decrypt it, means this is encryption. A whole of it is encryption. This one. The first step, the first one is encryption. This one. The whole of this one is encryption. This is encryption. Please write down, this is encryption. And this step here is going to be what? Is going to be decryption. Decryption. We are going to decrypt the message. Okay, we use the same number of keys. Same number of keys. Okay, we use the same step. So you can take like this one. The key, let the key be like in between. Okay, we use a key to decrypt. We can use the key to encrypt. Okay, so we in the decryption. Okay, in the decryption. All right, from the decryption process, what do? We take add round as the first step, and you're going to do the inverse of shift row, inverse of sub key, add round. So the thing which we do from the decryption, instead of using the sub byte, what do? We use inverse sub byte. Important point. Shift, we use inverse shift row. What will be the inverse? Remember how do we calculate the inverse? We have to calculate the inverse of every bit which is there. It is done internally. This is going to be the inverse mixed column. As you can see to the important point here, from the for using the encryption, let me write it here so you can at least one column you will understand. Okay, at least one round you will understand here. Let me have it like this one. Okay, so this was, let me take this as a ciphertext. Here we're going to have a ciphertext of 128-bit. Now, when I'm going to move from this ciphertext, what do I have? I will have add round key. I'm going to decrypt it. This is encryption. Please note it. This is encryption. Now I'm going to have a decryption here. So this is add round key here. This is add round. Okay. Then in this add round, I'm going to put a ciphertext. Ciphertext is going to be the input, right? Whereas in encryption, plain text was the input. Here, PT, plain text was the input. Okay. Here, ciphertext is the input. Okay. Ciphertext is the input in a round 1, or let me write like this one so you can understand. Why do I write like that one? Look here. For the decryption, I'm going to take a ciphertext as input. This is a ciphertext as input. CT as input is going to go to the add round. This is for decryption, clear? Add round key. And the add round key is going to be followed by the inverse shift row. Now, the inverse shift row is going to proceed inverse sub byte. Okay, inverse sub byte, and inverse sub byte is going to follow add round. Okay, it's going to follow what? It's going to follow when you start from the last. Okay, this is when you start from the last, because the last column, the last key I mean, the last shift, the last round means round 10, for example, if we are using 128-bit, the round key, it will be like this way. It will follow the same way. It will follow this step: add round, inverse shift, inverse subbyte, inverse subbyte, and inverse subbyte is going to be followed by add round, the add round, okay. The add round is going to be followed by the mix, inverse mix column, mix column. This is going to be the inverse mix column. This is the last, this is known as a last round. Okay, starting from the last round. Now, the rest of the round, as you can see to the diagram which we have here, we start from the shift low subbyte add round, shift low subbyte add round. So we continue to follow the same road. We continue to follow the same road: inverse, shift low, inverse subbyte, subbyte, like this one. Whereas here we start from subbyte, shift low, mix column, add column. Here, inverse low, inverse shift low, inverse subbyte, inverse mix column, like that. So this is there for the decryption, from the description side, decryption side. So this was all about AES structure, or Advanced Encryption Standard structure. If you have any question, you can ask. You can ask if you have any question. If you have a question, it's a time to ask. If you have a question, you can ask. Okay. All right. So if there is no question, then I may tell you what you'll be doing as a assignment of this one. Hold on. Hold on, as I'm looking to the material. Hold on.